Okay, we'll now be clicking General tab. Click the tab. Then we have here the property, the specs, the support, the load, and the material tab, sub-tabs or sub-options. Alright, so first is the property tab, which is already opened here. This is the property dialog box here for the whole structure. Since we will be designing reinforced concrete structure, we will be defining those members. All these items are the members, and these are the nodes, okay, and so on. All right. Okay, so we have to define the property of each of the members here. So since again we are designing reinforced concrete, we will click define. Okay, now we will define the beams and the columns here. So click rectangle, and let's say for the beams, let's say the depth of the beam is, let's say, 0.3 meters, and the width or breadth of the beam is, say, 0.25 meters. Click add. Okay, then close. So we have defined one section of the beam. If you want to add more, you click again define, then rectangle if it's a rectangular beam. Okay, because you can also have a circular column. Okay, so you can also define it here. So we have rectangle, another beam, let's say at the roof beam, let's say a smaller section, let's say the depth is 0.25 and the breadth is 0.2, then add. Then we'll define the columns here, the column members. Okay, so let's say that's 0.3 by 0.3 square section. So again define, then click rectangle, ZD and YD is 0.3. This is a 0.3 by 0.3 square. Add, close. By the way, make sure your material is concrete here. Okay, concrete, because we are designing concrete structures. Okay, so we have here a rectangular beam, a rectangular section 0.3 by 0.25, rectangular section 0.25 by 0.2, and a rectangular section 0.3 by 0.3 with materials all concrete. Now we have to assign these items we have defined here in our model. So first we will assign this section 0.3 by 0.25. So this section will be for these beams. Okay, these are all my assumptions. You can change that later in the design phase if it will fail, if it will pass, if it's too much, too deep or too wide. You can adjust that one later. First we have to assume the sections, concrete sections first. So we have here 0.3 by 0.25. Then I will assign it on these beams selected. So again, if you want to select a member, left click. Then if you want to select more members, you press the control key. Hold the control key while clicking. Okay, that's it. Then release the control key. Then choose this one. Oh, sorry, I've already chosen that one. Then select. Then since I've selected, you can choose how to assign this section 0.3 by 0.25. So since I selected the beams already, you can choose this one. Okay, if I have not chosen that one, you can choose use cursor to assign. So I will assign this using cursor. Click assign, then click each member one by one to assign that property number 1 or R1. Okay, so rectangular one is 0.3 and by 0.25. So it's clearly labeled here that these beams are rectangular 1 or 0.3 by 0.25. So use the same steps for the other members. Okay, so click this one. This is for the roof beams. Use cursor to assign. Click, 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 and click. Okay, so lastly we have here the columns. So you assign the columns. If you have problems with assigning, you can use the arrow keys so that you can rotate up and down, left and right for ease. Okay, so to check if you have assigned all the members with materials, you can click here, the 3D rendered view button. Okay, so we have here those assigned with sections are clearly shown, and those lines that are not assigned yet are rendered as lines only. So we have here at the bottom columns, or the columns at the ground floors are not yet assigned, so we'll close this one, then assign. Use cursor to assign. Click the bottom columns to assign. Arrow keys to rotate. Okay, then again check using this one. Okay, so that's your model, 3D model of the frame. Alright, so we close it. This is just for checking. Okay, so that is how to assign properties for concrete, reinforced concrete structures. Now we'll skip specs because most of the time these specs are for steel. Okay, so we'll now go to support. So we'll define the support here on these nodes. On these nodes we need to put supports here so that we can design this structure, and also we can also design the footing for this structure. So when you click support, there's a dialog box here, supports whole structure dialog box. Only one option here, no support, so meaning we don't have support yet. So we have to create a support or define a support for this structure. So we have here create. So we have here the create support dialog box. So we have options here. You have fixed, you have pinned, you have fixed butt, you have enforced, and so on. Okay, so we'll be using the fixed support for our structure. You added one, so this will be our fixed support number 2 or S2. Okay, so next is to assign that support to the structure. So again, use cursor to assign. Click S2, use cursor to assign, then click assign button, then get your cursor near to that support and click. Alright, we have created the supports for this structure. So we are done with the support. Now we go to the load part. Okay, so click load. Now we have to create a primary load case. Okay, so first primary load case would be, let's say, live load. Type live load and press OK. Alright, then you assign loads to the members. Now in this tutorial I will not teach you how to compute for the loads carried on these beams, on this structure. Okay, it's on your own to compute the loadings on these beams. Okay, so let's say this is just an example. Okay, so let's say we have here, for this beam, we have here a load of 10 kilonewton. Okay, 10 kilonewton, uniform load of 10 kilonewton. That's so you click this member because it's a member. Okay, member. Then we have here some choices of member loads. Okay, so we have linear, varying, trapezoidal, triangular, trapezoidal, hydrostatic, and so on. But we are here for the uniform force. Okay, this one. So the uniform force of 10 kilonewton all throughout the member. So since it's all throughout the member, we have here D1 as 0, D2 default as 0, then D3 will be 0. Just put 10 here. But since we are using the direction global Y, and our global Y here is going up, okay, going up, so we have to use, and since our load is going downward, so you have to use negative 10. Then that's kilonewton per meter. So you can add or you can assign. Since we already highlighted this member, you just can directly go click assign. Okay, so that's the negative 10 kilonewton in this beam member. Okay, so same for the other beams. Let's say these two beams are, let's say 5 kilonewton. So click uniform force minus 5, then assign. This one is, let's say 8, and this one also is 8. Click that one, minus 8, assign. Then if you have here this one, let's say there's a thrust reaction here. Let's say a concentrated force of, let's say 20 kilonewton. So at the nodes. Okay, so since it's at the nodes, you use nodal. Then since we are going for a uniform force, you use this F, force along Y. Okay, if you want the moment, load, moment along Y, so we have to use this one, force along Y, again minus, let's say 20 kilonewton, add. So you assign it, 20 kilonewton, assign using cursor, assign, click here, click here, click. That is assuming our thrust reaction. Okay, if you want a lateral load, you can use Fx. Okay, plus or minus Fx if you want it in a positive direction or negative direction. Okay, so basically that's our live load design, our live load case, live load case. Okay, so we have here our live load case. That's our first instance, our first load. Okay, so next we need to add the dead loads. Okay, so the dead load, you will click the create new load, again another primary load. Okay, so primary load, click, let's say dead load. So this will be the load from the slab, from the beams, from the partitions, from the other loads other than live load. Okay, so let's say we have here dead load. Okay, so again, same process. Uniform force, let's say -5, add, assign, assign, assign. Oh, sorry. Okay, let's say for the dead load, all members, B members, all B members are to have 5 kilonewton. This is just an example. Okay, so -5, then assign. So we have here the dead load. If you choose the dead load here, if you want to choose the live load, that's also the live load. If you want to choose the dead load here, dead load. Okay. So one important item to consider when you compute the dead load is you do not compute the weight of the members here, the weight of the beams and the weight of the columns. You only compute the weight of the slab, the weight of the partition, and so on, but you do not compute the weight of the members here, the columns, the beams, because STAAD will compute it on automatically when you set it to its self weight. We have here self weight. Okay, so you need to add self weight. Sorry, yes, self weight, then factor is -1 going downwards, then it's along the y axis going downwards, it's -1, then assign. Okay, so your dead load now, which is 5, which compose of partition loads other than the beam and the column loads, and the self weight, which is the weight of the beams and the columns computed by STAAD. Okay, so now we are now ready to combine live load and dead load. As you all know, you have the combination of live load and dead load in your design. We have, I'm not sure if it's still 1.4 the dead load plus 1.7 live load, but just to show you how to combine, click new load, click combination load, click OK. Then let's name this new combination as 1.4 DL plus 1.7 LL. Alright, so we have here the 2 primary load cases on the left, then we have the factor, and we have the new load combination here. So we named it 1.4 DL plus 1.7 LL. So first, the live load. What's the factor for live load? We have 1.7, so type 1.7, then click live load, then transfer it to the other side. So we have 1.7 for the factor for the live load. Then we have 1.4 for the dead load, then transfer it to the other side. So 1.7 live load plus 1.4 dead load, that is our load combination tree, which is named 1.4 DL plus 1.7 LL. Click OK. Now it will show here. So we have live load, we have dead load, and we have the combination load of 1.4 dead load and 1.7 live load. Okay. Again, 2 primary loads and 1 combination load. You can add more primary loads as you want. You can add more combination loads as you want. That is just to show you how to create those loads. Alright. Then we will have to skip material because we already defined the materials for this structure, which is concrete, as you can see. Alright, we're done with the general tab. Now let's go to the analysis and print tab.